Alright, so now that we have a game plan for solving equations, it turns out that equations can be labeled as different types. We can categorize them into different situations. So it turns out that the three big situations, some equations are called conditional, some are called identities, and some are called contradictions or contradiction. So let's go ahead and use our equation solving skills to figure out what happens and why we use these terms, conditional, identity, and contradiction, to label equations. So in the first one, we're kind of back to the last video where we have a fraction. So as I shared with you guys, my favorite way to handle these is to get rid of the fraction. So the LCD is 3. So I'm going to take this side and multiply it by 3, which means I have to take the other side and multiply it by 3. Working with my fractions here, right? If you want to write that as 3 over 1, the 3's divide out. We're left with 2 times the quantity 4x minus 6. On the other side, 3 times 5 is 15. Simplifying further, we have to distribute. We get an 8x minus 12 equals 15. After the simplification, we're trying to bring terms to the same side, so that 8x is in a good spot, but minus 12 isn't. So we're going to add 12 to this side, and whatever we do to one side, we do to the other. 15 plus 12 is going to give us 27. To finish this equation off, we have to reverse a multiplication by 8, so I'll divide by 8. And so we end up with the solution, x is equal to 27 divided by 8. And this is why we call this type of an equation conditional, because the truthness of it, the only value of all the real numbers that we have, the only one that works is x equals 27 over 8. So the truthness of this equation depends on the condition that x is equal to 27 over 8. If you don't satisfy that condition, nothing else works. It's the only one that basically makes the statement true. So these types of equations are called conditional because their truthness depends on a particular situation being met. In this case, x is 27 over 8. Most equations that we will work with will be conditional ones. As a matter of fact, everything we've worked with at this point has been conditional. We always came up with some value of x that's going to make the situation true. Another type of equation is an identity. So let's just go through our work and see what happens here. We have to simplify both sides as much as possible. Thankfully, there's no fraction, so we don't have to worry about that. But distributing, we get a 12x plus 8. And then combining like terms, 12x minus 3x is a 9x, and plus 8 minus 6 would give us a plus 2. And you probably already see something interesting right here, because notice that one side is exactly identical to the other side, hence the phrase identity. If you're not fortunate enough to see this, if you keep moving forward, right, if I subtract 9x from both sides and subtract 2 from both sides, we end up with 0 equals 0. And this is something that we know to be always true, right? One number is basically equal to itself, and one side is basically identical to the other. So what this means is we have an identity, and in terms of solution, it means that x is equal to all real numbers. Pretty significant, because this means any value of x you can dream up. My favorite number, your best friend's favorite number, it doesn't matter what x is, everybody's going to make this equation true. So it's because it's an identity. One side eventually looks like the other. So very special case. Not all equations are identities, but they do come up from time to time. Contradictions. To see what happens here, let's go ahead and continue to solve. We have a lot of simplification to do. Doing my distributions, on this side we get 10 minus 5x. We're taking the opposite of a sum, or we're subtracting a sum, so that changes all my signs. Here we're doubling up and subtracting, so we change signs and double up. So negative 2 times 5x is a negative 10x, and a minus 2 and a minus 2, or a negative 2 and a negative 2 gives a plus 4. Combining like terms still, right here we get a negative 7x. And these two, 10 take away 5 leaves us with 5. 3x take away 10x leaves us with a negative 7x. And we have a plus 4. Alrighty? So we're done simplifying. Now as we try to move some things around, let's add 7x to both sides. And while I'm doing that, we can be subtracting 5 from both sides. Right? All the x's I like to move to my left. All the 9x stuff I like to move to my right. So playing that balancing act, look what happens. These cancel out, leaving us with 0. These terms cancel out, and then 4 take away 5 leaves us with negative 1. And so we kind of end up with a statement that is never true. Right? I don't know about you guys, but 0 is not equal to negative 1. They have two completely different locations on the number line. We use them to quantify two different realities. So these are never true. And so that basically means that if this solution phase gives us something that's never true, that means that this equality is never true. So that means we have no solution. You cannot find a value of x that when you substitute into the equation will ever make this true. No value exists that does that. So these types of equations are called contradictions. So in sum, when you're solving equations, there's 3 types that you'll run into. Some will have no solution. They're contradictions and lead to statements that are just flat out not true. Some equations are identities. Then you go through your equation solving technique, you'll end up with something that's always true, so everybody's going to work. And then most equations are conditional, meaning that if we go through our equation solving technique, our game plan, we end up with a certain condition that will make the situation true. So therefore conditional. All right. While I'm on the topic of categorizing things, right, let me kind of go one step further. In the last video, we ran into an equation where I solved by just following the idea of multiplying both sides by the LCD, and it worked great with that one. But some equations are also called proportions. What happens in a proportion is we have a fraction equal to a fraction. Very complicated, but I have one fraction on the left-hand side, and I'm claiming that it's equal to a fraction on the right-hand side. And it turns out that when we're solving a proportion, another way to solve it is to use this real famous trick called cross multiplication. Now, I hope you guys, you've been with me for 2 weeks now and listening to my videos. I have never used the terminology cross multiplication until this point, right? Because it only applies when we're solving a proportion. If you're not solving a proportion and someone's asking you to cross multiply, you better run away from them. They don't know what they're doing mathematically, all right? Because proportions are the only things that use cross multiplication. And so as the name suggests, the way we can approach this is we're going to build another equation by cross multiplying my fractions. So we're going to multiply the 8 to the numerator 3x plus 1, and we're going to multiply 4 to the numerator 3x minus 5. When you cross multiply, we're starting with an equation, so we're ending with an equation. Cross multiplications end with equations, not fractions. And so now we're basically back to solving the equation. Doing a distribution, we get 24x plus 8. On this side, doing a distribution, we get 12x minus 20. We can subtract 12x from both sides. We can subtract 8 from both sides, right? And we end up with 12x equals negative 28. Alrighty. And then to solve what's left, let me bring it over here. I would divide both sides by 12. Alright, and 12s cancel out, and we're left with negative 28 over 12. Alright, this answer looks a little bit different than the one we got previously, but it's not. This fraction needs to be simplified. 28 is 2 times 14, and 12 is 2 times 6, so the 2's cancel out. 14 is 2 times 7, and 6 is 2 times 3, so they cancel out. So we end up with x equals, right, negative 7/3, which is the same answer we got when we just approached this with our LCD clearing the fraction trick. So some equations are proportions. They're fractions equals to fractions. When I have a proportion, I can solve it with cross multiplication. And then back to the original idea of this is what we call a conditional equation, because its truthness depends on x being negative 7/3. So this is not only a proportion equation, but I could also label it as conditional. Alright, so be careful with your cross multiplication. You only use it if you are being asked to solve a proportion. Alright, so that should wrap up section 2.2. We're going to advance the ball even more in the next section where we solve equations with more letters in them. So lots of fun ahead. I'll talk to you guys later.